Hello guys, welcome to my YouTube channel. So today we are going to discuss one of the easy problem from the lead code. This is one of the very important problem I would say because the technique is that we are going to use in this particular problem. It's very simple, but it can be used at multiple places. So let's quickly jump to the description. So there is a given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. So it is asking that we cannot create the copy of the array, right? Because if we are able to create the copy of the array, then the problem is very simple. Um, we can just create a new array and we can copy all the non-zero element first, right? While traversing and then just copy the number of zeros which are present in this array. This is one technique, but this solution we shouldn't be implementing because that is what it is asked, right? Other technique, that I can think of at the moment is what you can do is you sort the array. After sorting, what will happen? This will become 0, 0, 1, 3, and 12, right? And then there is a way of rotating an array. So you rotate the array um, by that number of times. The number of zeros are available, right? So there are two zeros available. So you rotate the array by two. So after rotating, what will happen? This will become this, right? And this is what it is asked. So this is another technique, but the time complexity in this case would be n log n, right? And also the rotation time. So, oh, sorry. So let me just get it again. So the time complexity in that case was n log n and into, let's say, the k times we are, rotating the array, right? So k times. Actually, not this will not be the k times, this will be like plus k, right? So this is our time complexity in this case. So basically, in overall, we can say that this is n log n, right? But how can we improve this? So there is another way of doing this problem, right? And that approach is very good and it's very simple as well. And that approach is going to be used in many other problems, which I will discuss later in other videos. So basically what we can do is, let's write this array first. So what we can do, we can take a help of one variable which can keep track of last zero uh, number, right? Last zero index actually in the array. So initially we can say that, okay, let's consider that at 0th index there is a zero. Even though if it is not there, that's fine. So initially this is the value we can go with the assumption that a zero is present at a 0th index, right? Then what we can do, we can iterate over the array and we can try to find if there is a zero, right, at I. So I is basically starting from 0 to n. So there is one condition, either 0 can present or 0 is not present, right? So if 0 is present, right, we don't need to do anything. We'll just move to the, the next um, index, right? If it is equal to 0, we don't need to do anything. But if this is not a 0 element, what we need to do is we can swap, okay? And we have to also increment the last 0 index by 1. So this is the technique, right? So in this case, if you see, just if we'll dry run that, how it will work is, let me just clear it out, right? So what I'm saying is, so when the I is 0, right? So this is also 0. So my last zero index variable will be zero because I'm not going to do anything, right? Now when I will become 1, so I know that this is not 0, right? So I will swap it. I will swap with this index and this index. Okay. So my array will become like 1 and 0, 0, 3 and 12, right? And my last 0 will be incremented by 1. Okay. Then again I will increment I and I will become 2. Now this is 0, right? Um, so this is 0, then I will not do anything. I will just increment I, right? Now I become 3. So once I is 3, right? At index 3, the number is also 3. So I know that 3 is not equal to 0. So I will swap this index with this index. Okay. So I will swap this one with this. So this will become 1, 3, 0, and 12. Okay. After this swapping. Now I will increment I equal to 4. At 4, this is 12, right? And in the previous one, it could have, incremented by 1. So this would have become 2, right? Because now this 0 is at 2. And my array will be look like this, right? Now at 4, I know this, the value is 12, which is not equal to 0. So I can again go ahead and I can swap it, right? 4 with 2. So this will become 3. So this is going to swap with this, right? So this will become 12. This will become this array. So this is how we are going to, solve this problem. Okay. So let me quickly write the code for it. And basically these kind of, this technique can be used even if you have seen this problem like move or, sort the array with 0, 1, 2, right? Sort the array of 0, 1, 2. That kind of problem you would have seen in the Geeks for Geeks. Or if there is a question where they are asking you to move all the negative elements, at the starting of the array, right? If it is something like that, or move all the particular element to the right end of the array. So this is the same technique we can apply. Um, Same technique we can apply in all different, conditions what they are asking for without using extra space. Yeah, so let's quickly jump to the coding part, right? So let's say I'm saying that I will have a variable which will keep track of the last index of a zero. So last zero index I can give a name, right? Which will be at a zero. Then I will simply run my loop, right? That will go till my length of nums. Okay. So what I have to do, I have to simply check whether my nums I, right, is not equal to 0. If that is the case, then what I can do is nums of I and nums of last 0 index, I can swap. Last 0 index, right? I can swap it. And at the same time, I have to increment my last 0 index. Okay. I have to increment my last 0 index by 1 because I swapped it, right? So my position would have been incremented. I think that's all we have to do in this problem. Now we have to simply, uh, we don't need to return anything because that is what expected by this function. So this would have been, sorted. Okay, last 0 index is this. Okay, typo mistake. Let me correct it. Okay, so it's taking time. Now it is done. So it's look correct. Let me just submit it. and that's all. So that's how this technique, without using extra space, will be able to solve this problem. So generally in this problem, what we have to see is, so whatever the number it is asking for, whether move it to left or it to right, we have to just, somewhere we have to start storing that particular number index, and then simply try to move that element either in the left or in the right based on the asked questions, right? And then that also will change whether you are starting from the left or starting from the right. So that's all for this problem. If you have any question or doubt, please comment in the comment box. We'll see you in the next video. Thank you, guys.